Typhoon Mangkhut was one-of-a-kind storm, descriptive and fitting of a superstorm for the Philippine locals who heard the name Ompong. It had ravaged through the state of Luzon, across Cagayan province, and then crossing over into the South China Sea, steering towards Hong Kong, just a year after Typhoon Hato. In all, it had caused 134 reported fatalities and $3.77 billion in 2018 values. In this video, we will go through the meteorological progression together of Typhoon Mangkhut, almost as if we were there, the day ground zero, taking a trip back, starting as if we were forecasting for the JMA or JTWC on the very early hours of September 6th, 05Z. On September 5th, 2018, 10 AM Hagatna, Guam time, located 8.6 degrees north, 159.7 degrees east. Sea surface temperatures around 30 degrees Celsius. The environmental conditions were very favourable, with these warm seas, low vertical wind shear, roughly 5 to 10 knots, and enhanced equatorial outflow supporting the initial development. This was the beginning. A low pressure area developed west of the Marshall Islands. The disturbance rapidly organized as convection began consolidating around a developing center. The development. Zahir imagery showed a consolidated low with sporadic pulse thunderstorm activity, increasing from minus 70 degrees Celsius ecotops around the center of the low to minus 80 to minus 83 degrees Celsius ecotops scattered, quickly shed apart, leaving an open exposed low, with cells from the ITZ, also known as the Intertropical Convergence Zone, surrounding the low. The GFS predicted path initially was due west, and then west-northwest towards Taiwan. Could this be true? Tropical Depression 26W by a Joint Typhoon Warning Center JTWC at 10 AM Hagatna time on September 7th was classified. The initial intensity forecast was 20 knots 1 minute sustained with 1006 hectopascals for pressure. Forecast models such as the GFS and ECMWF, the Euro model, indicated gradual strengthening with projected west-northwest movement. At this point, JTWC shows between September 7th 0 UTC and 20 knots, and at September 8th 0 UTC at 40 knots, to increase 10 knots in 12 hours around September 9th 12 UTC to become 65 knots, an equivalent typhoon with a peak intensity of 135 knots on September 12th, likely due to bullish forecast on long-range intensities. Development. Storm located over northern Marshall Islands, 12 degrees north, 168 degrees east, 1,510 miles from east of Saipan, 1,540 miles east-southeast of Pagan and Rota, and 1,570 miles east of Guam. Any signs of a CCC or central cold cover were not present. To give an overview of what a CCC is, it is a region of a broad bank, upwards of 300 to 400 kilometers typically. Atypical is considered above that. For example, in late July 1996, Typhoon Gloria had a CCC of 780 kilometers, which is enormously large and near record size. And it is of a very intense cloud cover, a bank of at least minus 70 degrees Celsius ecotops, atop a weak circulation that tends to have an expanse of cirrus cloud cover, with a central cover as high as minus 80 to minus 90 degrees potentially. And another perspective, the record ecotops seen from a tropical cyclone was near Australia are minus 102 degrees Celsius, discussed by Ebert and Holland 1992 paper. And this CCC indicates weakening or interruption, the intensification of the core and the rain bands surrounding the cyclone. Often, for a system to intensify from it, it has to remove it and generates a strengthening CDO bank instead to form an eye. The system had a well-defined intensifying CDO provided on visual imagery. The cirrus cover was thinning, and on infrared, -80 degrees cloud tops was sporadically present, typically pulsing up and down, making it easier to see the CDO on the visible rather than the infrared. The cells in the rain bands comprised of updrafts and downdrafts, were moving poleward and recurving outward, showing more gradual strengthening. Vertical wind shear was around 5 to 10 knots. The intensification to Tropical Storm Mangkhut was now declared on September 7th, 10 p.m. Hagatna time, located 10.1 degrees north, 155 degrees east. The system had obtained 35 knots. That's just the low-end tropical storm status, one which sustained with 1000 millibars low pressure. The system had reached stage 1 on the CDPS scale, the cyclone destruction potential scale, and it was of low damage potential on this stage 1. Key features: large convective banding developing all quadrants, moving fairly fast, propagating by strong surface flow westward. This pattern continued, typical for the Hadley cell. When demonstrated on the global atmospheric circulation model, where storms are propagated from northeast or easterly trade winds close to the ITCZ, and as the system develops a robust core, increasing in wind speeds, the tropical storm has a propensity to spin poleward, provided by the Coriolis force, acting on rotating objects on a spinning spherical body, the Earth. The system had a structure qualifiable of a Dvorak score of T 2.5 and just under T 3.0, given a central core. Often when propelled at fast speeds, it can often bubble up and collapse as it experiences rapid changes and is in incomplete vertical alignment. For tropical storms that have favourable environments, it is a common pattern observed, i.e. Hurricane Beryl of 2024. It minimally requires more central convection in a circular shape, defining a CDO, spiraled rain banding, and a decent outflow poleward persisting for a couple of hours to increase the Dvorak score quickly, all the way up to T4.0, reaching hurricane status on the Saffir-Simpson scale. The track and the wind field expansion. Closest points were near Bikini Atoll, Enewetak Atoll. Tropical Storm Watch was issued for the island with a population of 900. Saipan, Rota, Hagatna on Guam. The forward speed of the system at this time was 9 miles per hour, moving west-northwest. Wind field radii expanding with tropical storm force winds extending 60 miles from the center. The expected track intensity, now suggested by the GFS, is expected to increase in size in wind field radii, maintaining tropical storm, expected to become a typhoon south of Guam, increasing considerably potential 2.5 to 3 times the size and explode intensity over the western Pacific with the west-northwest track all the way towards Taiwan. Model intensities such as the CTCX, a high-resolution guidance model, at this point was consistently the most aggressive on the intensity of the storm, having a bias that really forebodes the future potential of a storm of such magnitude that could actually hold. Environmental parameters. At this point, the system was forecasted to maintain fairly low shear environment and on the slight increase as it moves west, with SSTs remaining steady but RH relative humidity values from 80% to 65%. At this time, sea surface temperatures and oceanic heat content were something of a very important consideration. Sea surface temperatures 30.5 degrees Celsius up to a maximum of 32 degrees Celsius. Bearing in mind it only takes 31 degrees Celsius for tropical storms to experience extremely favourable conditions to undergo rapid intensification despite any absences of OHCs, the deep water content values. High oceanic heat content levels were exceeding 80 kilojoules per centimeter squared, and soon westward a spike from the Philippine Sea extended to the central open West Pacific is a hotspot, increasing to 200 kilojoules per centimeter squared. Normally during peak season provided ample solar heating and environmentally boosted stratification, deep water mixing, supporting rapid energy intake, on top of the continuously supplied SSDs. On September 9th, 12 Hagatna time, Typhoon Mangkhut was classified. It was located 15 degrees north, 155 degrees east, winds of 75 miles per hour, and a pressure of 975 millibars, 600 to 650 miles from Saipan, Pagan, and Rota, 700 miles from Hagatna, Guam, 200,200 from Manila. Forecasts calling for the same output, therefore a very high uncertainty environment was still here. Despite not necessarily being a favoured model, often due to the inconsistency making it unreliable, it was CTCX calling out that no one took into consideration as the most representative forecast intensity, calling for Category 5 peak in the Philippine Sea region. Typhoon Mangkhut propelled at greater than 20 miles per hour due west, considered a moderate typhoon translational speed. Structure was generally improving, classic forward spiral banding out ahead of the storm, often recognized as a predecessor rain event. This is where the uplift of convection pertains for a period of time, and out ahead of the storm's motion, where significant, often the bulk of precipitable water values are, and can cause torrential rains, causing significant rainfall accumulations with tropical moisture. It can cause at least 6 inches of rainfall, all the way up to 20 inches. An extreme example is Hurricane Helene 2024, although most of the predecessor rainfall event contributed to large totals on the landfall site rather than inland. The CDO, central dense overcast, was curling up, and CB's convective bursts were rotating cyclonically in a visually more rigorous pattern, often representative of vertical alignment completing. With the LLC, the low-level circulation is vertically matched in cross-section beneath the mid-level circulation. This also tends to favour more convection around the centre, even if areas along the certain flanks of the storm become exposed slightly. Typhoon Mangkhut, by September 10th, 0Z, Hagatna time, was located 15 degrees north and 158 degrees east, intensifying quickly. Now with winds of 85 miles per hour, pressure of 967 millibars. The perspective of speed. The storm was only now 400 miles from Hagatna, closing in on Saipan at 300 miles away. Guam, Rota, Saipan, Tinian all under typhoon warning. Unfortunately for Saipan, this will not be the last time during the season this will occur, where shortly later Typhoon Yutu would devastate, becoming potentially the strongest storm to make landfall in US territory. Landfall at 190 miles per hour, 894 millibars. The structure of Mangkhut, after collapsing slightly, it had rapidly re-intensified, with CBs all over the centre, the most likely region to experience explosive thunderstorm activity in this violent tropical cyclone. By 6 a.m. Hagatna time, September 10th, located 15 degrees north, 149 degrees east. For context, the longitude decreases as it translates westwards. It intensified to 90 miles per hour, pressure of 955 millibars, rapidly deepening pressure and relatively lower pressure than winds than typical for storms in the Western Pacific of the exact same intensity, sometimes indicating very favourable conditions for development, and an eye could appear at any time. Structure was well maintained, evidencing strengthening phase and spiraled coiled up shape like a snail fossil, often showing rapid transition to major status as the convection wraps around, collapses the coiled shape, and develops at the same time as that's happening a new CB ring, creating a more circular Dvorak CDO ring structure. Really distinct cyclonic outflow, whilst inflow channel is sustained well on the southern flank. The wind field radii was now growing, particularly northeast and northwest quadrants, the favoured strongest flanks in the northern hemisphere cyclones, while the southern flanks take longer to become equal. largely showed the strengthening in the northern quadrants, being worse for the islands as they are located to the north or the west. Converting to PHT, Philippine time now. At 6:30 p.m. Philippine time, September 10th, Typhoon Mangkhut had intensified moderately to 105 miles per hour and pressure of 962 millibars, passing over Rota, part of the northern Mariana Islands, at just 5.6 miles from Sinapalo, making a direct impact. That is, of not being a landfall, but the eye wall conditions are still felt on the island. 10 p.m. Philippines time, September 10th, located 14 degrees north, 144 degrees east. Typhoon Mangkhut had steady state of intensification of the warm Pacific waters to 115 miles per hour, 950 millibars. The system was far from any land ahead of the islands, just impacted. Using the time between to bows the favourable ambient environmental conditions. By this time, the CDPS cyclone destruction potential scale had increased to 4, meaning extensive damage could be done upon impacts at its current intensity. But the problem wasn't the current intensity, it was what it could become in the future. Maintaining a larger northeast and northwest quadrant, the system was slowly but surely broadening with tropical storm force wind fields, expanding with a broader expanse of convective cover, with the eye wall hoisting the typhoon wind field radii much larger, likely double than the initial size at this point, which is typical and was expected. Models had peak intensity forecast at this time of Category 4, largely due to interpretation of more significant vertical wind shear, creating moderate favourable conditions rather than very favourable. SSTs were nearing the peak, reaching the extremely favourable thresholds that is really needed for storm to rapidly intensify, peak SSTs reaching 30 degrees to 31 degrees Celsius. An eye feature began to open up, possibly after the event of an eye wall replacement cycle, but no full sequence had captured to fully support it, but is likely with an intensifying typhoon facing dynamic environmental changes promoting contractions of the inner eye wall whilst the outer new ring forms. But a key importance was that the typhoon's CDO had rounded out further despite banding dissipating. It reassembled much more of a Dvorak score of 5.5, the major status. At 4 a.m. Philippines time, Typhoon Mangkhut had intensified further, increasing the nerve of the Philippine residents after seeing intensification phases of storms this far out becoming very violent typhoons as they approached the islands. One such story being Typhoon Haiyan 2013, still being in the minds of the residents. The storm was located 14 degrees north, 142 degrees east, with winds of 125 miles per hour and a pressure of 948 millibars. CDPS increases to 5, devastating damage potential. The northeast and northwest quadrants quickly widened out, just as the models predicted. No warnings were issued yet, as it is far from land masses. JTWC had already seen the potential of this storm this far out and issued a forecast of Category 5. The super typhoon was now possible. The GFS model had not predicted a mainland Philippine landfall, thus predicted peak Category 5 intensity north of Batanes. Could it be true, or will the typhoon forecast become even more uncertain? Typhoon Mangkhut, despite under 20 knots of vertical wind shear, the highest forecasted yet for the system, had very little in the way of unfavourability, with Dvorak suggesting the eye scene type. The main phase of typhoon development towards intensification was still developing, with intense below minus 80 degrees Celsius sea breeze continually wrapping around and keeping it up shear, convection keeping the eye away from the greatest vertical wind shear influence, really emphasizing that this system was compact and the structure had little influence on the dynamics of shear breakdown. The unstable but intensive subsidence at the core made it appear as if the typhoon eye was wobbling, but rather actually showing the nature of intense new updrafts under the cold sea breeze pushing around the eye, creating a stronger CDO ring with subsidence at the center, starting to decrease the water vapor values at the center as the strongest winds begin to follow the circular compact ring of the eye wall. 10 a.m. Philippines time, September 11th, located 14 degrees north, 141 degrees east, Typhoon Mangkhut had intensified to 140 miles per hour with a pressure of 935 millibars. In the short turn of 6 hours, the system had intensified to Category 4 status, obtaining violent typhoon status. The CDPS had increased to 6, catastrophic potential was now on the table. Wind field radar had largely not changed, suggesting a balance in the structure of the typhoon to continue the intensification with the Dvorak structure type it has maintained. System has not had any significant fluxes in the ambient environmental conditions in the time, but the strengthening was certainly evident on the water vapor imagery satellite, where the blues or the drying out of the eye really ramped up, where the appearance of the typhoon became spike ball-like, more common in high-end Category 3s to mid-Category 4 status. By 10 p.m. Philippines time, September 11th, located 13 degrees north, 138 degrees east, Super Typhoon Mangkhut went all the way to rapidly intensify, as typhoons can do when approaching the Philippine Sea, with the warmest SSTs and the highest OHC values. It became a Category 5. Winds of 165 miles per hour, pressure 910 millibars. Cyclone was rapidly deepening in pressure. Coincidingly, as Typhoon Mangkhut intensifies, the CDPS rises to a stage 8, a catastrophic potential. The wind field largely extends out in the northeast quadrant. Typhoons that tend to be broader in size with wider eyes have a greater likelihood of the strongest winds in the eye wall in the northeast quadrant, and on a ground relative level, typhoons typically moving west or northwest means tangential winds, basically the strongest winds rotating the eye wall, or known as the Vmax, are working in the same direction as the translational wind, which is where the typhoon is moving towards. Virac, Philippines, under 1,000 miles away, a potential landfall site for the storm. Uncertainty still lies, and prevention of miscommunication or relay means that no warnings were yet issued in the region or elsewhere. Nonetheless, forecasters' minds, intensity forecasts were now possible as high as 180 miles per hour. Could this be? The system obtains much deeper blues on water vapor imagery satellite, suggestive of significant subsidence in the eye where the drying out is taking place. The much more pronounced eye has allowed for organized CBs to wrap around in a tight, rapid fashion around the core, -80s and above, approaching the rotating cyclonically in good upper upflow and anticyclonic outflows were taking place. The structure is more in line with a classic donut-shaped CDO ring with no banding ahead. Analogues to this could be described using Typhoon Haiyan 2013, Typhoon Gay 1992, and Typhoon Meggy of 2010. Yet, however, it is discernible the eye is yet to become more circular, and a northwest quadrant still needs to be filled in with some exposure, partially due to some wind shear, as well as in this occasion due to the nature of the structure and the persistence of the smooth CDO ring must be seen to warrant a greater Dvorak score, as opposed to different typhoons, for example, such as pinhole eye typhoons, which can be exceptionally powerful for a short period of time, where Dvorak observations are not as easy to represent true intensities, especially with an unstable eye contributing to erroneous Dvorak scores being issued, as well as visual confusion on the nature of the eyeball intensity as it weakens, strengthens, or collapses. By 10 a.m. Philippines time, September 12th, by some miracle it had weakened just slightly to 160 miles per hour, with a pressure of 910 millibars, still due to a phase of decreasing pressure whilst the winds remaining the same. And largely at this time, it had been a Category 5 for 30 hours. This would be already of the very small, less than 5 percentile group, which is very rare, but since conditions loomed favourable and largely unchanged on the broad scale and atmospheric synoptics, with little induction of wind shear by a mid-level trough. By 10 p.m. Philippines time, September 12th, Typhoon Mangkhut, located 14 degrees north, 133 degrees east, had really shown a phase of intensification again, increasing to what was likely near the maximum peak intensity through the life cycle with winds of 185 miles per hour and a pressure of 896 millibars. The system has quickly ballooned in its wind field radii, with almost double in each quadrant, with equal peak radii extending in the northwest and northeast, as more typical in northern hemisphere cyclones. The CDPS has risen to a maximum of stage 10 extreme potential, very little in the wake would withstand such extreme conditions, likely sustaining very significant damages. Chances of landfall increasing were in confidence on Santa Ana. By 4 a.m. September 13th, a near perfect eye shape was coming to place with renewed convective banding extending to the west of the circulation, demonstrating a strong low-level convergence and upper-level divergence surrounding the system, supporting explosive updraft growth, more so showing a very favourable environment, and structure-wise the core is very stable, allowing for interpretation of lower pressures. By 10 a.m. now 54 hours has passed and Mangkhut remains a Category 5, albeit just slightly weaker to 165 miles per hour and a pressure of 901 millibars. The very unique circumstances of a typhoon forming so far west and translating due west for the majority of its life cycle with little in the contribution to create unfavourable conditions. Unfavourable surface pattern meant as the system became so intense it was able to further modify its surrounding environment, such as inflow-outflow balances, and sustaining it to only where subtle changes in intensity could occur despite large-scale changes in the structure, i.e. CBs warming slightly as old updrafts collapse and renewed development occurs. The primary talk is how the distance is churning down quickly, only 450 miles to Virac, Philippines. It is only a matter of time till landfall is now expected. At 10 p.m. Philippines time, September 13th, Signal 1 warnings are issued for all of Luzon, including all of Batanes Islands and northern Samar. By 4 a.m. Philippines time, September 14th, located 15 degrees north, 127 degrees east, winds of 175 miles per hour and a pressure of 903 millibars, Mangkhut has completed an eyewall replacement cycle, or an EWRC, where the inner eyewall of the typhoon collapses and outer concentric ring forms farther out and is contracted inwards, where the inner eyewall is replaced by a larger one, forming a larger eye in the process. And during this process, the winds temporarily decrease slightly, still of Category 5 intensity, and for the shape and size of the typhoon, it is not susceptible to such great changes to intensity. But wind field radii across all quadrants of the system increase dramatically, and where storm surge becomes more prevalent. CDPS remains stage 10. It is not often with such maintenance of the highest stage of the CDPS scale. The system is only 260 miles from Virac, and now significant decisions for emergency large-scale evacuations are taking place. Signal 2 warnings are now issued for Isabela, with additional Signal 1 warnings for Mindoro, Mabast, and Marinduque. Now 10 a.m. Philippines time, September 14th, located 16 degrees north, 126 degrees east, the system began to collapse slightly, reducing to intensity of 160 miles per hour, 912 millibars. Notice the more frequent fluctuations, EWRCs, can occur on multiple occasions, and often when such high intensity moving through dynamic changes and in new environmental conditions. Even just more subtle changes in wind shear can induce more eyewall replacement cycles. The wind field radii becomes more east side loaded as the CDO of the central ring structure of the typhoon reorganizes slightly, with a reinvigoration of CBs initiating in the northeast quadrant. This is a cyclic pattern that is induced with cyclones, as the coldest CBs initially and over time, once fully reorganized, can be in the northeast quadrant. Signal 3 warnings were now issued for the dangerous concern of a landfall site, imminent in the later days, particularly near Aurora, Isabela, and Cagayan. Signal 2 warnings were now represented the rest of northern Luzon, whilst to the south, Signal 1 warnings remain for the potential of a few severe gusts in the Manila region. By 10 p.m. Philippines time, September 14th, located 17 degrees north, 123 degrees east, Super Typhoon Mangkhut had reached back to near the lowest initial pressure, with winds of 175 miles per hour and a pressure of 899 millibars. The system is now less than 100 miles from Divilatkan and 115 from Santa Ana. A signal of full warnings are now issued for Cagayan, northern Apayao, Abra, northern Isabela. September 15th, 4 am Philippines time, 18 degrees north, 121 degrees east. Typhoon Mangkhut has made landfall at remarkable numbers rarely seen even on typhoon and cyclone capital of the world, Luzon, with winds of 175 miles per hour and a pressure of 898 millibars, gusts up to 210 miles per hour on satellite estimations, with unparalleled potential of wind-related impacts as the western eye wall comes in, northeasterlies blowing in, and some realized by Pagasa of around 16 to 20 foot storm surge. Landfall intensities of such are uncommon in the region, but have occurred. Looking back at some of the strongest landfalls on the Philippines, these are of some of the strongest observed. Typhoon Mangkhut 2016 made landfall with winds of 195 miles per hour and a pressure of 874 millibars. Typhoon Haiyan 2013 made landfall with winds of 195 miles per hour and a pressure of 879 millibars. Typhoon Goni of 2020 made landfall with winds of 195 miles per hour and a pressure of 882 millibars. Typhoon Zeb of 1998 made landfall with winds of 185 miles per hour and a pressure of 888 millibars. Typhoon Mangkhut of 2010 made landfall with winds of 185 miles per hour and a pressure of 890 millibars. Exact precipitation numbers are unknown, but certainly devastating flash flooding has occurred with induced rockfalls, the collapsing of rocks due to extreme saturation between the binding of sediment strata and landslides, the ejection of masses of debris along a slope through downsloping induced by heavy precipitation, saturation from through flow and surface runoff, as well as gravity acting downwards, causing the most unstable part of the region to fall. Sometimes on mountainous regions, scree landslides can occur. The extent is not done yet, as the system traverses on the mountainous terrain known as the Sierra Madre, causing rapid weakening of the system, but as it's still so large, it is kept intact, the central core of its circulation, with warmer cloud tops and spontaneous sea breeze erupting primarily due to orographic lifting, where as air parcels descend the higher terrain east, this causes change in the pressure and the temperature, inducing lifting of parcels to the LFC, or the level of free convection, and these are seeds to new updrafts and downdrafts which form the CBs in this terrain. By 4 am Hong Kong time, September 16th, located 20 degrees north, 116 degrees east, it has now winds of 105 miles per hour and a pressure of 955 millibars. Due to the broad nature of the cyclone, it retains CDPS of stage 6, still catastrophic damage potential. The category number does not often dictate the output or the significance of the typhoon, a limiting factor of the Saffir-Simpson scale, especially in the larger interpretation of normal people being impacted, is hard to comprehend. The system, due to the broad cyclonic rotation, is still impacting near Pratas Island, Philippines, but is now moving due northwest towards Hong Kong, only 200 miles away given the smaller size of the South China Sea. The core of the system has now some spontaneous CBs close to the centre, provided the centripetal force is acting on the new updrafts, and it will cause it to rotate closer to the retightening centre. But the system is largely irreparable to allow for more significant intensification in a relatively short period of time as compared to before, as the system would need to undergo many of the same processes it initially took during the early stages of development to allow for redevelopment of higher intensities. Fortunately, this caps the maximum limit for the peak intensity. Red typhoon warning for Guangdong and Signal 8 warnings were issued for Hong Kong and Macau. 10 am Hong Kong time, September 16th. Located 20 degrees north, 115 degrees east. Typhoon Mangkhut weakened slightly to 100 miles per hour, pressure of 960 millibars, on the cusp of Category 2. 120 miles from Hong Kong, Signal 9 warnings now issued. It is uncommon for Hong Kong to see the greatest impacts of typhoons' life cycle, but rather to see the remnants of or weakened systems, That being said, some systems that come to mind with significant impacts, such as Typhoon Hatu 2017, Typhoon Solar 2023, and Typhoon Haikui of 2023. One of the trends remaining for a more near constant intensity maintenance is due to SSTs roughly 3 degrees Celsius lower than the peak in the Philippine Sea, around 28 degrees Celsius, and lowered OHC values, as well as a forecast 20 knots of vertical wind shear. 10 PM Hong Kong time, September 16th, Typhoon Mangkhut makes landfall on Hong Kong. Signal 10 warnings were issued just prior to landfall. The occurrence of 2 maximum warnings on 2 different countries' warning systems is rare, let alone for a system to have for Philippines and Hong Kong. In fact, there aren't really any analogues for this case. Typhoon Mangkhut made landfall with winds of 100 miles per hour and a pressure of 961 millibars, rough estimation of satellite, particularly with such a large wind field radii contributing to widespread wind-related damage inland and further inland as it gradually decreases in wind intensity. By 9 PM Hong Kong time, September 17th, JTWC monitors of Mangkhut is no longer active, whether it is classified as a remnant low near Funing, China. Looking back, Typhoon Mangkhut caused immense devastation, causing 134 fatalities, which we are fortunate is not greater, particularly in the Philippines, due to the Sierra Madre, the shield of Luzon. As said previously, $3.77 billion in damages were done, taking years to recover, and still by the local residents when they are asked vividly, they remember the day it happened. Typhoon Mangkhut produced 53 ACE, or accumulated cyclone energy, which measures, just like the adjusted Fujita scale, the time of the life cycle of the typhoon and the duration of each category intensity throughout the path, producing a value. And often the season value can reach up to 330 ACE. Typhoon Mangkhut produced ACE on the high end of long-lasting tropical cyclones and the highest of 2018 cyclones globally. And the best performing models were 2 separate models. The HWRF produced the most accurate tracks of the system, often within the tightest of the uncertainty cone to the actual track. This often what leads to high reliability in the outputs of the runs of intensity and tracks generated by the HWRF, as opposed to other high-res guidances in modern forecasting of tropical cyclones. The best performing for intensity was actually the CTCX, which is unusual as it often is the most unreliable, most outlandish when considering forecasting, but comes to show relying on one model output is not enough to generate confidence. In the memory of all those impacted, to recognize the unique synopsis of this meteorological event, I hope this does justice. Thank you all for watching, and I will catch you guys in the next video.